Hello and welcome to today's ROV live stream. Thanks that we already have quite a few views on this live stream. My name is Christian Katlein. I'm your host today for this live stream. I'm a CIS physicist and robotics specialist at the Alfred-Wegener-Institut in Bremerhaven, Germany, where I'm also located right now, but my colleagues are out on the ice. And thanks to improved new communication technology, namely the internet service of Starlink and Space and OneWeb, we are this year able to, for the first time, provide live streams from the Arctic and give you a little insight into our work with our ROV Beast underneath the ice. So today we are looking at some dives underneath the Arctic ice, trying to investigate optical light propagation in the ice and also looking at different properties of the ice. So right now we actually have kind of a bit of situation going on. We have currently, or we just half an hour ago had a polar bear coming into the flow, and everybody out on the ice had to leave the ice and retract to safety. Luckily, that situation has just resolved, and the polar bear has gone away to a safe distance again. So it is safe for us again to go, or for my colleagues to go onto the ice. And yeah, that is a very standard thing that happens during work in the Arctic. Polar bears are the kings of the Arctic. They are very precious animals, but very powerful animals. So definitely nothing that you want to pet or be in other close contact with. So for the safety of our work and also mainly for the safety of the polar bears, if there is a polar bear spotted by the various guards and watches that are posted always on top of the ship when somebody's working out on the ice. A polar bear was noticed apparently that it was coming closer to the vessel. Usually they lose interest pretty fast because they're interested in seals and not in humans and electronics. So that is also what apparently happened now, but that is something normal on the ice. So yeah, I just got noticed from the ship that my colleagues are going back onto the ice right now. So we are going to have a live ROV transmission in 20-25 minutes or something like that. Until that, I want to introduce you a little bit to this live stream, and this is the first commented live stream that we offer from our ROV Beast. So this is also my first live stream. So if you have any feedback, write us or put it into the comments. Also, really feel free to use the chat function of this tool. So here on YouTube, you can just write any kind of question into that chat. We will archive what I'll try to answer these questions during watching the videos. So I will try to comment what will be going on, but in the meantime, it's very great if I can answer some of your questions that you have and that you have about our work, what we're doing, how we're doing it, etc. Maybe as a start on that, I give you a little overview of where we currently are. And I have here a map display that you can see, and you can see the islands of northern Russia here, mainly Franz Josef Land on the right side of the map. This is a real-time display that my colleagues are also using on the ship to plan their voyage. And then you see the colored surfaces, and that is the sea ice coverage this from today, actually, that has been measured by satellite. And we use that on the ship to determine where we're going. So the gray line is the track that Polarstern has been taking for the last 4 weeks, actually. They have been in the Arctic going pretty far east and then going north, and you see a few wiggles in the track where they did some station work. And then they had some station work right at the North Pole, which has also been in the media, and where we actually started our first test live streams. And now they're proceeding back south because the expedition is going to end in Bremerhaven in the beginning of October. So they are working their way down south the ice. And what you can see also from this track is that the track has been remarkably straight this year. Uh, there's still significant ice, and it is really challenging also in parts of the time, but most of the time Polarstern is only using about 30% of their full engine power. So they have made very good progress, which is a very bad sign because that means that the ice is rather thin and it's easy to progress through. Then the ship is usually stopping for several days on a floe, and that is also what we are doing currently. And the ship is then on the floe trying to yeah, work on the ice. There's a lot of work also in the deep sea. So you can see that the ship is currently at a position of 85.4 degrees north. So that's roughly 450 kilometers away from the North Pole, and at a latitude of about 60 degrees east. And this 60-degree east transect is something that we researchers investigate quite a lot, or well, it's still the Arctic, so it's not a lot. But oceanographers try to go with the vessel for straight lines and then do regular water column observations of temperature and salinity so that we understand the salinity or the circulation in the polar oceans. So that is why the ship is in generally trying to follow these straight lines. So you see that soon the ship will be going to hit some easier ice conditions, and then the ship will return to Bremerhaven. We also have some other live data from the ship, so I can show you the latest meteogram of the ship. So we currently have an air temperature around -5 degrees where my colleagues are working, and we have about 7 to 8 meters of wind for coming from a northerly direction. So it's typical late summer Arctic working conditions that they are facing. It's not too cold, but -5 is already a temperature where you have to dress properly and get things safely. So maybe let's continue a little bit with an introduction into our ROV system so that you know what we are dealing with while we are looking for the time. So please feel free to post any questions that you might have into the chat so that I can answer your questions. As I said, the live stream is going to start, or the live footage from the Arctic is probably still some 20 minutes away because we had a situation with a polar bear on the ice. My colleagues are just returning to the ice because it's now safe again to work on the ice. So we have a little delay on the live pictures. During that time, I'd be happy to answer your questions. And this is an introduction about the ROV vehicle that we have been using, and that is here the ROV that we call Beast. And yeah, this is basically an observation class ROV vehicle. It's an Ocean Modules, that's a Swedish company, M500 vehicle, and it's fitted all over with scientific sensors, and it's geared for under ice operations. So the main first thing is the vehicle is not operated from the ship, but actually my colleagues are putting a control container and the ROV and everything onto the ice, and then on the ice everything gets controlled. So this is the overview of the sensor suite that we are having on the vehicle, and of course you have some sensors like a scanning sonar that the pilot knows where they are. We have also a multi-beam sonar that we can use for mapping the ice thickness from underneath. We are probably not going to use that much on this dive that you're going to see today because these multi-beam dives are particularly boring to watch because that means that the vehicle is going for hours in a depth of 40 meters to produce a 3D map from the underside of the ice. That's not very appealing to watch. So what we're uh, mainly looking at today is the front equipment of the vehicle. So there we have optical sensors that measure the sunlight that is penetrating through the Arctic ice cover, which is very important to understand correctly because this is what's starting the whole ecosystem where organisms, little algae and zooplankton can live off. So this is a very important parameter, and that's why we are trying to measure the light properties. So we are measuring different light quantities, and we also measuring the spectrum of light. So we see at which wavelengths there's how much coming through. Then we're obviously also taking pictures up against the ice. We have still cameras. We have a little manipulator arm, which we mainly use to free ourselves in case we get stuck. And the main big thing that we have for you to see today is, of course, a high resolution video camera. And then there's also secondary video cameras on the front and the back of the vehicle that I'll hopefully also be able to show you, so that we can see something. Then we have additional sensors. So we have a CTT sensor measuring temperature and salinity on board. This is also measuring the oxygen content of the vehicle. We have sensors measuring nitrates, so nutrients in the water column, which is very important for the ecosystem. And we also have sensors that are measuring the optical properties of the seawater. So you can see it's quite a complex system, and my colleagues are currently probably in the process of starting it up in the Arctic, and we don't have real-time video images yet. So I'm actually very happy that we already have at least 50 viewers. This is much more than what we anticipated. So great that all of you are watching and that you're interested in what we are doing. And I've seen in the chat that some people are also from pretty far away. So if you don't have a question, feel free to write where you're coming from or where you're watching from, so that we get to a little overview of where people are coming from. But really, I want to encourage you again to type any kind of question that you have related to this sea ice work that you're going to see into the chat. Be interactive, and that makes our wait time for the live video signal from the Arctic a little bit more interesting. So while there's still no questions in the chat, I can maybe go on to a question that I got as reply on one of the Twitter announcements when we announced this tweet, and there was the question if this is at all related to some of the activities that, for example, NASA is planning to explore icy moons in the solar system, and which is, of course, a very fancy topic. In general, I would say, of course, driving this technology forward, the remotely operated vehicles, in challenging areas like the Arctic, this is definitely also helping that cause of these extreme space missions. However, this mission today is not directly related to such a mission. We are not actively involved in any project trying to do extraterrestrial exploration, but we are definitely cooperating with colleagues that are involved in that. The Alfred-Wegener-Institut has a few scientists and engineers involved in these projects, but these are, of course, still a little bit far-fetched, and we are mostly focusing on planet Earth at the moment. And as the Mosaic expedition has shown, there's still many things that we don't really understand well in the current CI system. So we are trying to figure out what is going on and to learn more about the CI system. So let me see. No, the chat still doesn't have any questions. So maybe I can talk a little bit in the meantime about the technologies that we're using for this live stream. Just a year ago, this live stream would not have been possible, plain like that. There have been multiple streams from ROV dives from other institutes, for example, from Schmidt Ocean Institute or from the expedition vessel Nautilus, etc. But they are not operating in polar regions. And in the non-polar regions of the Earth, you can get actually quite reasonable satellite coverage that is not good for really easy Netflix streaming for everybody on board, but it is good enough so that you can get a optimized video stream through and um, provide this. In the Arctic, we have the problem that none of these high throughput satellite systems exist due to orbital limitations because you can't put a geostationary satellite up there. And that meant that we were relying heavily for our data internet on the what is called Iridium, the Iridium network. And just for you to know that the internet connection until last year on Polarstern was consisting of a monthly uh, traffic possibility of 1 GB for the entire ship, and that cost about 10 to 20,000 euros just this internet. So you can see it's quite an extreme challenge to provide connectivity up in the Arctic. And this year, this has suddenly changed dramatically. Um, so the Starlink and OneWeb constellations now enable a polar coverage with high bandwidth. So they have seen up to 300 megabits of bandwidth, and that finally enables us to do these live transmissions from the Arctic, so that we can really yeah, send you these signals. And this is fairly new, and I'm very happy that we have this chance so that the general public can also take part in some of what we're doing. And because it's very important and it's a very unique perspective to get. And just seeing the underside of sea ice is something that not so many people have seen. So finally, we got a question in the chat, and thank you a lot for that question. And the question is if I can talk a little bit about the sensitivity of the instruments and their particularly pH, oxygen, and nitrate sensors. And that is definitely a challenging topic. These are chemical sensors measuring the properties of the water column. And this is also, they have to operate under extremely harsh conditions. So this is a very challenging application. So let's start, for example, with the nitrate sensor. That is the Suna sensor built by a company called Satlantic. And it is a UV absorption spectrometer. So it sends out UV light and looks how much is coming back from the other in the other end. And then it derives the nutrient content from that. However, that is not so, it works fairly well in waters that we have reliable nutrients. These sensors are usually used in like wastewater management, etc., and there you have quite high nitrate levels. However, in Arctic surface waters, we struggle a lot because yeah, the concentrations of nutrients in these waters are so low because they're so productive, the nutrients get used up so that the concentrations are very low. So it's a really challenging thing. So I don't want to put out numbers. You can look up the data sheet for the Sunas Atlantic sensor on that, but also the numbers that manufacturers write on their data sheets don't always apply under Arctic conditions. Similarly for oxygen and PA, and there it comes down a lot also to calibration of the sensors. For the pH sensor, for example, I would say that in the Arctic we achieve an accuracy of approximately zero point 0.1 uh, pH value. So somebody who's dealing with pH measurements in the lab, this is terribly inaccurate. For somebody who is doing long-term pH measurements somewhere in an extreme environment, this is actually a good value. So you see that sensing these is very challenging, and it always depends on the application of what we're doing. For example, if we on the graphics, there's also mentioned the fluorometer, and the fluorometer is measuring the chlorophyll content of the water column. So how much algae are in there, and what you're actually measuring is the fluorescence of the algae, and that itself is not directly related to how much algae are there, because algae can be more healthy or less healthy, and then they react differently to this fluorescence and or fluorescent light. So it is quite a challenge to derive that. So it is very hard from these sensors sometimes to get a definitive value as you would get when you take a water sample and you grab it and you take it to the lab and analyze it on high resolution machines back in the lab. But what it really enables you is to measure profiles, to measure vertical profiles, to measure spatial high resolution and understand also spatial patterns of how these things are varying. So it is quite important to have these sensors on a variety of platforms, and in combination with some high reliable water sampling lab measurements, then you can really get to a good image. Talking about the other sensors, with the light sensors, they are as sensitive that you can still measure reasonably some differences in, let's say, what we would call twilight in somewhere in Europe or America. Um, they are not super low light sensitive because they are measuring the whole spectrum, but we can even have seen that we can see some lunar signals of moonshine, etc., when during the Arctic night. Um, that's one reason why we're mostly working during summer and during the day to get the maximum solar input. Then we got another question if bottom melt is still ongoing in the Polarstern's location. And maybe for that I can go back to the map where Polarstern currently is, and you can see that Polarstern is somewhere here in the Eurasian Arctic, and I can also give me a second. I can also deactivate here this sea ice concentration layer, and then you see where Polarstern is currently in the central Arctic basin. And the question is if bottom melt is still going on. So bottom melt is the amount of ice, or is the way ice is melting from underneath. Ice can melt from the top, and ice can melt from the bottom. From the top, it's mostly solar energy incoming, and from the bottom, it's mostly related to how warm the ocean is. We've seen in summer there's a lot of energy also coming into the ocean. So usually at the end of summer, the water column is still pretty cold, pretty warm. Warm meaning relative to the seawater freezing point. That wouldn't be warm water if you want to swim in there. It would still be one of the coldest waters you've ever been swimming in. But referred to ice and sea ice, it's really really warm waters. So yes, bottom melt is usually going on quite long into the season, and we have seen that, for example, during the Mosaic expeditions, that in these locations where we currently are, the bottom melting of the ice can still go on far into October, sometimes even November. Before then, ice growth at the bottom already starts. And this is very counterintuitive because you have the surface already looks very much like a winter situation, and you think, okay, here everything is freezing. You're working out on the ice. It's cold and you're freezing, so it's hard to imagine, but under the ice, the thermodynamics of the ocean is still leading to the fact that the ice is still ablating. This varies, of course, a lot from where in the Arctic you are and exactly how it's going. I haven't seen live data from on the ship at the moment, but we will be able to see that also during the ROV dive. Probably, and I'm pretty sure that the bottom melt is still going on. I would be very surprised if bottom melt is not going on anymore. It's probably slowing down though, because as you've seen, we already have kind of passed the sea ice minimum, which is typically meant to be at around 15th of September. Then we have the minimum extent of sea ice, and after that, after the rule of thumb, sea ice is growing again. But yeah, that growth mostly refers to uh, lateral growth in many areas. So it's not really yeah, the bottom growth that stops immediately, or the bottom growth that starts immediately. So that is quite a challenge. Okay, so I just got another message from the team on the ice that they still need 15 minutes more. So feel free to send me any other questions that you might be interested in. Um, Otherwise, I'll come up with topics to talk about with myself. I can put up the picture of the polar bear again. We have some delays because the team had to leave the ice due to a polar bear, and this is very standard situation in Arctic fieldwork. The polar bear is the king of the Arctic, and they determine what is possible. We are just guests in this area, and it's our responsibility not to harm them. So that means that we take a lot of precautions to not disturb them and not not interfere with them. The problem is the polar bears are usually very curious animals, and they don't know what we are doing. So they see a big research vessel and they can be coming walking up from far away, and they are top predators, so they are just interested in checking out what is going on, um, who is there, and who is doing what. And unfortunately, if a polar bear is checking out who that human is that is working, that's usually not a very good situation for the human. So that means that when we are working on the ice, we always have multiple watches put out on the ship, and then we also have guards on the ice with bear deterrents. And once a polar bear is spotted, immediately it's assessed how far it is away, and then we organize a safe return to the vessel, get everybody back to the vessel because the bears can't really climb on board the vessel. So then the situation gets reassessed, and depending on what is happening, how the bear is behaving, um, we try to either scare it away from the equipment. There might be equipment that could be hurtful for him. Like if we have, for example, with the ROV, we have some high voltage cables out, and or some sharp ice drills or stuff like that, then we try to scare it away from these parts of our installations. But otherwise, we usually try to not interfere with them. But you have to imagine if you're a polar bear living in the Arctic and you're walking up to this 120-meter big research vessel Polarstern that is very loud, making a lot of noise and very weird smells that you don't know. Also, a lot of the bears get uninterested after a few minutes again, and when they are lost their interest, then they just walk away, and then it's usually very quickly safe again to work on the ice. However, they might come back, and that means that the situation can change all the time. And this is one of the biggest differences to the Antarctic. In the Antarctic, you really have only to deal with penguins. Uh, the biggest problems you might have there, maybe with leopard seals, but they are not as crazy as polar bears. So penguins, they don't do you any harm. You have to keep your distance. Um, Usually they don't know about the distance rules, so they come close to you anyways. But yeah, it's a really a challenging situation with polar bears. So my colleagues had to retreat to the ship, then they reassessed, and the polar bear moved away. Now they're trying to set things up, and as always in the Arctic, things also sometimes take longer. Um, that's a problem with setting up live streams. So either you can just start a live stream and then you guys don't know about it, which is also a challenge. Or we announce a time and then we have the issue that there might be a polar bear or something else popping up. There can also always be a problem with a ship or the equipment. So on one of the earlier tries, we had a failure with the equipment, and of course these things can happen. And I got another nice comment on the chat. Who refers to the ham station on Polarstern. Okay, so somebody apparently there's depending. Sometimes there's of course also radio amateurs working on Polarstern, and some of them put up their gear. And it's actually very interesting. When 10 years or 12 years ago I did my first expedition on Polarstern, we still had a full radio officer, which has now been replaced by a communications officer. But that is uh, that is long gone times, and now there's only a few people who take their own private radio equipment there and keep the good old traditions up. Thanks a lot for that. And now we got another two questions, and one question is there a connection between ice formation and geomagnetism, and why isn't conductivity measured? Um, well, the first thing is there is no direct or no known link between geomagnetism and ice formation. Um, there's no further link between these two. One could construct maybe some far-fetched effects of geomagnetism effects on climate that then affect ice growth, but otherwise there's no direct connections. And indeed, conductivity is measured. So I've talked about our CTD sensor, and that stands for conductivity, temperature, depth. And that means that we measure the conductivity of the seawater to measure the salinity of the seawater. We also do that in ice, obviously not from the ROV. Then we have to take a sample of the ice core to measure the conductivity and the sea ice. And then another question is, are underlight conditions also measured in par? Can I think about it? Similar to terrestrial conditions, which algae absorbing a part, and F par tells you about the photosynthetic activity. It is very similar of what people are doing in terrestrial ecosystem measurements. So yes, par is used and measured, and as I said, we are measuring the full spectrum. The full spectrum of the light, and that means that you can always calculate par. PAR stands for all the non-biologists here, for photosynthetically active radiation, and that means that basically all light between 400 and 700 nanometers, which very much coincides with the light that we can see, and that's also the light that algae are using. So we are measuring that wavelength range, and we are looking at that, measuring it in different ways and with different sensors. Um, we are not much looking at the fluorescence directly from these sensors. That's more through active fluorometry. And most of the photosynthetic activity, that's really measurements that done in the lab and not in situ. I won't go into more details on the specifics of the photosystems of the algae. Also, firstly, because I'm not a biologist, and second of all, because it's very complicated, and I guess not all our viewers are interested in that much detail. So I hope that this answer is enough for you, that we are indeed measuring PAR, and then we have a fluorometer, a separate fluorometer to measure algae properties, which is a wet labs eco triplet. And yeah, somebody says penguins are pretty dangerous as well. Yeah, well, of course they are. Can look quite dangerous as well, but usually they are nothing compared to the big white furry animals, um, who are these. Um, yeah, I'll just pause for a second, and then I'll be back. Okay, sorry for that little break. I just needed to interact with some other coordination here on the stream. So if you have any other questions, feel free to join the chat and ask questions. I'm glad there's already so much interactions. I'll look through if I've already missed something. No, I think I haven't missed. I have answered all questions so far. So maybe I can tell you a little bit also before we get some video from the Arctic, which should be popping in any minute now. We should the Alfred-Wegener-Institut. Oh, and then actually I just got finally a live stream. Now I just need to set up a few things. So we see the first live images of. Now let me see.
So everybody out there, can you see and hear us?
Okay, so we have now live images from the Arctic. I don't get audio yet.
Good. Yes, clear and loud. So that's great. Welcome to the Arctic. So we are a bit late, but we have the best excuse, I think. Our work this morning got interrupted by a polar bear showing up at 8:30. So that was 2 hours ago, and that interrupted all measurements on the ice. And we had to deal with the situation, but since 50 minutes, we're back on the ice. Right now, the vehicle just went down in the water, and we have to wake up our transponder system. Yeah, so bear with us for a minute. Receiver test. Test passed. Okay. Run. Wake up. All transponders. Okay, the under ice position we get from 3 LBL transponders where the vehicle sends a pulse to each of them, and based on the return times, we get the position triangulation. But since we haven't been diving for 2 hours now, we have to wake up the system before we get back any positions. Yeah, I mean, you can just say that. So we are live on here.
We are live. One nation, one station.
Yeah, no worries. Still make up the transponder. So why we, and we can have the mouse. So why we still set things up, maybe a little introduction to ourselves here. So I am Marcel Nicolau. So my name is Marcel, coming from RV in Bremerhaven, working with this ROV since a couple of years and mostly working with optical data. Then we have the background with the colorful hat. That's Julia. She's diving.
Okay, so you can see we are live in the Arctic. We can see my colleagues Marcel Nicolaus and Emiliano Cimoli and Julia Regner currently in the control cabin. The stream seems a little bit jumpy from time to time. That is when the satellite connection is not that great. I can see that you also over YouTube you get some real-time sound. Unfortunately, here I have a little sound issue that I can't hear the sound. I know you hear it. So I'll just let the chat running and check what they are saying as well.
Of Polarstern, you can still see the little piece of the gangway. And then you find on the top right, that's our front camera. That's the main camera there, and with some navigation data. And on the top left, we have 2 more cameras on the vehicle. One is looking backwards, that's the top right one, and one is looking forward but a bit down, that we can see our manipulator on the left one. So mostly you probably want to watch the main video. The mission of today is optical measurements. So we will soon start going up to a depth of 2 meters. Ice thickness is roughly 1 meter here today. And then we'll diving a grid of regular patterns to measure how much light goes through the ice, and with the spectral camera to map possible algae content and life in the ice with a hyperspectral camera. Awesome.
Okay, so you can now see that my colleagues have started diving. The internet connection is dropping out sometimes, and this is due to the satellite constellation. So they are now working on doing under ice diving. So right now I see that there's not so much audio coming from on board, so I can explain you quickly what you can see. So you can see the 4 screens at the moment, and you can see on the top left you can see some pilot awareness cameras, and then you can see the ROV main camera. You can see an outside view from the ROV cabin, which currently just shows the gangway hanging onto the ice. And then we have an inside view of the control cabin for where my colleagues are streaming and controlling the ROV. So the person that you see on the left is the pilot. Okay, so let's now go through the different cameras that I can show you. So first of all, we start with the ROV main camera, and you can see this has some overlays of the under ice situation. So you can see the vehicle's pitch and roll. You can see the vehicle's depth. We're currently at 2 meters where we're doing our measurements. And we have just passed one of the transducers for the acoustic positioning system. That has been this thing hanging in the water. And now you can actually see a first ctenophore, some zooplankton, and you can see we have passed a pressure ridge underneath the ice where the ice has been pushed together. And now we are back into a more even situation. We have more cameras that we can show, and that is some pilot awareness cameras. In the bottom left corner, you have a view of the manipulator, secondary view forward, and you have the backward camera where we see the cable, the so-called tether cable, that is yeah, providing the power and the data to the vehicle. If we go back to the front camera, you can nicely see some ice structures. Then we have a camera view here. This is at the moment a fairly boring view, and this is due to some issues. This is just an exterior camera that was supposed to show you the under ice deployment site. And you can see it in the far back. You can see a few little dots. That's my colleagues currently working on the ice. But unfortunately, there's not too much to see there. Most interesting then in the control cabin, you can see this is a lightweight container, isolated. My colleagues are obviously trying to figure out some trouble on the computer at the moment, and the stream seems a little bit unstable. You can see on the wall there's a heating because apparently we said it's -5 degrees, so it's not so warm. So it's nice if you have a bit of heating. You see the cabin is insulated, and the person to the left, she's currently piloting the whole ROV. So let's see what we're doing, and I don't know if you got that information earlier. So Marcel said we are going to do some under ice dives and mainly focusing on the optics. So let's see what is going to happen, and if you have any questions, let's tell it to the chat. Well, there's one question that I think is more of a joke. Where are the sharks? Well, there's no sharks here that far in the Arctic, and also no orcas. There's the biggest thing we've seen so far in our ROV work has been some seals. And oh, I see that the chat has actually been evolving quite a bit. So I just got a question: how thick is the ice, and if we are docked there currently? So the ice is indeed about a meter thick, Marcel just said. You can see they are diving in 2 meters depth. They are usually trying to keep a distance of 1 meter so that we have about a meter of thickness. And then yes, the ship is currently docked on a floe. So usually we try to keep the ship on a floe. This year we kind of have some trouble with the ship because we had a failure in the bow thruster system early on in one of the earlier expeditions. So Polarstern is not as maneuverable as normally. So the crew is currently working really hard to keep the ship against the floe so that people can work on it. Uh, they have found the situation, and let me check. My colleagues are just trying to find my sound. I give them some feedback. So yeah, it's about a meter thick, and the ship is pushing with the thrusters that they still have or functioning against the flow, and they also now anchor the ship in the front so that they don't need the bow thruster there. This is working well until reasonable winds, and only this enables us to actually do live streams because we are still at the moment relying on a hardwired Ethernet connection to the ship. So the last 100 meters are kind of all right. We were going through space with this whole stream, but the last 100 meters were the challenging part. We're going to work for that with that also for upcoming streams, but we are have always been yeah thinking that we would have access to the flow continuously. However, this is yeah, unexpected on this expedition that we don't have access to the flow all the time. So as easy as you can now see somebody just walking onto the ice with a polka for some equipment for some work. So we are working around this. And quite some comments in the chat. How quick is the ice melting from below, and can it melt from below? Yes, the ice is melting from below. If we come to the ice edge, the ice can actually melt pretty fast. It can melt up to like 30 centimeters a day in front straight. However, we are currently further north, so typical melt rates are more like uh, 1 to 2 centimeter a day or so, depending a bit on atmospheric conditions. As I said, it can be much more as well, can be less. Very much depends on winds, on ocean turbulence, ocean heat, also on the type of ice. So right now you see. Let me switch on the RV main camera. There you see the best things. You can see that this level ice. You see some melting from underneath, and now you can see the first are the marker poles. My colleagues have deployed these marker poles through the ice so that we have a double backup on our positioning system, because acoustic positioning under sea ice is not working so easily. So we really need to make sure where we are, because a measurement for the scientist, of course, only valuable if you know where things are. So you can see a bit of these light structures in the video, and you can see these bright patches and these dark patches, and these mostly come from the melt puddles on the surface. And you can see that there is on the surface on the surface camera. Let me quickly switch to that camera. You can see that we already have a quite uniform surface with quite some snow. but just a few months earlier, there were quite some a few weeks earlier, there were quite some melt puddles, etc. And where we have these melt puddles, there's also a lot more light coming through the ice. And even though we have now a snow on the surface, this structure persists throughout the early autumn season, and you can see these dark and bright patches underneath the ice. It's not directly related only to the ice thickness, but also to the optical properties of the ice. You just also could see a little jellyfish, a comb jelly, floating by, and yeah, right now it's mainly level ice that we are investigating for the optical properties to see how the ice looks from underneath. And you see quite some of these comb jellyfish. This is gelatinous zooplankton that is floating underneath the ice and living off the algae. And I want to remind you again, feel free to use the comment function here on YouTube to pose your questions, anything that you're wondering about in the video or otherwise, and I'll try to answer them. Just got a question in chat if we have salinity sensors on the ROV to identify brine sinking down to push the global conveyor belt. Of course, during ice formation, not when melting. So yes, we do have salinity sensors on the ROV. I've quickly showed a picture before. I can show an overview of the vehicle again. Here you see the ROV Beast at the moment, how it's mostly configured. And in the bottom there is a CTD sensor that is measuring the salinity of the ocean water. And it's usually not well, it's very tricky to actually measure the brine that is falling out because that can be very localized, and it's very hard to measure that. You usually see more in larger scale oceanographic observations. But you can measure it. The ROV is just not the best platform for this. So there's another question coming in. What is on the ocean floor? Is there methane hydrates if so far from the surface? So actually, this is a completely different topic. So our ROV work here on this expedition, we are focusing completely on the sea ice and on the surface. Alfred-Wegener-Institut is also working on the deep sea and also this cruise. There's people working on the deep sea. However, that's not part of our ROV observations here, because this vehicle has a maximum depth rating of about 300 meters. So there's not much we can do here. But apart from that, as I'm not a geologist, so I don't want to comment much on the methane hydrates. But I know that they are mostly, these stuff are more related to continental slopes, etc. And but yeah, don't quote me on that. So that would be something to ask some specialists in another live stream, or I'm just a surface ice specialist. So on the surface here, you now start seeing some nice structures, and this is apparently a structure where some thin ice at some point has been pushed together a bit and been moved up against each other. And there you clearly see some structures. We don't see the big heavy pressure ridges at the moment, but of course we're focusing also a lot on the level ice. But you always see some structures passing by, like here, for example, you see a little hummocky feature, and that you can also see quite clearly that there is some strong melting going on, because all the features that we see are fairly rounded and you can easily see how the melting is impacting the ice cover. So we got another question here. The question is how many different kind of ice is on, how much different kind of ice is on the surface. So this is a very difficult question. I don't know exactly what you mean. So all the ice that is floating there is floating sea ice, and sea ice is formed just from the ocean cooling, and it can have very different appearances depending on how old it is, how young it is. Here we're mostly dealing with first year ice that it has been is not older than 1 year. It has been growing here in further up in the transpolar drift stream. And then you have thicker parts, you have also some thinner parts. Earlier on the surface, a few weeks ago, you would have seen the melt ponds, which we can't see on the surface feed at the moment, anyways. So that is a bit tricky. But yeah, you can actually see if you look closely on the camera, just right of this flag, you can see some darker patches, and that's some remnants of these things. However, you can see actually here on some structures where the ice has been pushed together. You could consider that another ice type, which we call ice ridges. So it's hard to say how many different types of ice, but it also depends on how you classify it. So the question is, where's the warm water coming from to melt the ice from below? And that's actually a very great question. There's multiple ways. So see, we are measuring the optical properties here and look at how much light is penetrating. This light is first of all also heating the ocean column. If you leave anything in the sun, it's getting warm. And that also happens to the Arctic surface waters. So if we have much light penetrating during the summer, then we warm up the top surface of the Arctic Ocean, and that then really goes into melting in the end, melting the ice. So that is one way of how we are melting the ice. But then there's another way as well, and that is of course warm water from underneath. And there's again several processes what can bring relatively warm water up against the ice. The oceanography of the Arctic is, or at least the European part of the Arctic is in a way that there is a warm water mass underneath the polar waters, which is kind of the remnants of what we know as the Gulf Stream. And these warm waters that are also responsible for the warm climate in Europe, they penetrate into the Arctic and they subside underneath the surface. And then it depends how much mixing there is, and if there's, for example, strong storms or anything, these waters can be mixed into the top waters and contribute to melting. And then, of course, there's the fact that once the ice starts drifting out, for example, of Front Strait, there's warmer waters there just by the fact of being closer to the global ocean, and then the ice is melting more rapidly from the bottom as well. So, is the stream actually still moving? Yes, it is. We still have but we seem to have some intermittent problems. The problem with Starlink is that we have some intermittent outages when there's handoffs between different satellites. So sometimes we have really good connections, and then it's stuck for a few seconds again. So, but yeah, we are just keep watching here and look what we're doing. Okay, so now we have some moving pictures again. Apparently, satellite constellation is better again. So we can see quite some structure underneath the ice. The one disadvantage is, of course, for you to watch here, you're actually watching people working live. So my colleagues are right now, they are trying to do science, and even though Marcel did a little introduction in the beginning, they are actually trying to operate all the sensors. They're working. So that's why I'm here trying to tell you what is going on. But that also means that the ROV is obviously right now doing the optical survey. So they are following a predefined pattern to do kind of a push broom pattern underneath the Arctic ice flow, and they are not going to stop for something that is maybe interesting for a viewer. So you have to keep watching at the stream and looking. You see these a bit darker patches up against the ice, and these are actually air bubbles that collect in underneath the ice, and this is just due to the changes of solution of oxygen in the seawater, that bubbles form and get used again in the interaction between the ice and the ocean, and they collect obviously in some topographic features, and then you can see them as these nice mirrory or black faces underneath the ice because they reflect the light. So now we get a question of, are there any algae on the bottom of the ice, or are they below resolution of the cameras because it's optimized differently and further away? So yes, this is a, a very challenging question. While the Arctic ecosystem is very productive, and there's actually quite some algae produced, the concentrations are often not that high in a way that you clearly see that. As I said, right now we're doing an optical dive and we're not going super close to the ice, so we don't really see these algae films well. There might be an algae film just on the bottom of the ice. There's definitely algae living in the ice, but it's not as pronounced that we could see it here on green color. And currently, actually, also during the dive, what we're doing, my colleague Emiliano, who's for you the person on the right of the screen, they are performing hyperspectral imagery scanning of the underside of the ice, and this will tell them later how much algae are there, and that camera is more tuned towards detecting algae. However, you can sometimes see smaller pieces. You can see some amphipods hanging underneath the ice. Some of these floating things might also be algae, but if you look into the literature of CS algae, you might see these pictures of big hanging forests, but these are actually pretty rare and hard to find depending where you go. So I go to the main camera again so that you can see these features in nice high resolution. So there's another question as how large is the area that you are examining? And generally our ROV has a tether of about 300 meters length. That means we can go in a circle around 300 meters of our main access hole. And this means that is about a circle of 300 meters. And then we usually focus on an area of about 100 100 by 100 meters. So then, yeah, we we don't, yeah, we concentrate on that area for this high resolution surveys, and then we do larger surveys for individual things, etc. Okay, so there are more questions incoming. And that is okay. I'm back. So there's another question, or are they more specific in our algae in the Arctic because they are the main food, or Antarctic because they are the main food for krill? Yes, there are actually different species, and there is also the physics of the ice is very different. So in the algae or in the Antarctic, we have uh, much more of the algal communities also living in the ice, within the ice, also at the surface of the ice. And in the Arctic, you have kind of most of the stuff living in the ice bottom. So the algae are different, it's different species, but the general ecosystem function is similar. Um, of course, also in the Antarctic, we have a lot of krill, which is kind of not present in the Arctic, but other species are taking these functions. So the ecosystems are different, but they are also somewhat similar. So then my colleagues are currently readjusting the cameras because the outside view only showed you the thing. So they now took the camera inside, and yeah, so we can see that they're now trying to probably point it at one of the screens that is showing you where we are going. And yeah, exactly now Marcel is holding the camera so you can see, we see something that resembles an aerial image, but I don't think this is an aerial image of the current flow. Maybe it actually even is. Then we would be under some thin ice areas right now. And that could be the thing. And you see the orange line, and the orange line, that is the current position of the ROV. And you can see this little yellow dot moving, and that yellow dot is the ROV where they currently are in their profile. And you can see the mattress, the 100 by 100 meter grid that is going on. So this is a tool that the pilot mostly is using. Unfortunately, didn't manage to get this screen on the stream here directly, so sorry for this spontaneous video interfacing here. But you can see nicely how they managed to follow the survey lines with the ROV. And you can also see now we are apparently under a sheet of flat ice or very thin ice that they're trying to measure. And then we're going back further down south that line, going into the thicker ice again, and trying to do these transects. And these transect lines are spaced about 10 meters, so that the total square is roughly 100 by 100 meters, or whatever the current survey requires. So then there's another nice, interesting question from the chat, and that is, how does this ice compare with the midwinter ice that you saw on the Mosaic expedition? So yes, I was also on the Mosaic expedition, and the ROV Beast was going on the Mosaic expedition the entire year. So we had also winter dives during Mosaic, and the ice is of course different in winter. However, if you would watch a video and you would not necessarily see a very dramatic difference. What the main difference that you see in winter is that all the features that you see are not as rounded, and the ice underside looks a bit more jagged because the ice is not melting from underneath, or at least not in a significant way. There's some thermodynamic processes that also lead to melting underneath. But in general, that means that these features that we can see in winter are a bit more smoothed off. So you can see now also that we are getting back again into the thicker ice. You can see that now on the bottom left screen we are getting towards the edge of the flow. So apparently we're set up on the edge of the flow, and now we're going down underneath the ice again. So I guess in midwinter, we also saw some other things. We saw Fresnel ice formation, which is very great, interesting feature that we did not observe before in the Arctic, or at least not as widespread. And that is when the water becomes so cold that there's spontaneous formation of ice crystals in the water, or at any interface that serves as a crystallization nuclei. And then we suddenly started to have like it's a bit like if you're walking through a forest after a very cold night in winter, when you have all these crystals going on. And yeah, that is was a very glittery under ice situation, and it was very impressive and looked totally different. But of course, there's a lot of things that that look fairly similar. Okay, so my colleagues are currently just pointing the camera again at another feature of the system, and that is the screen you see there is the hyperspectral camera screen, and the hyperspectral camera is looking upwards against the ice, and it is measuring for each pixel in the image. It's measuring a spectrum of the light, so you can see how much light of how much wavelength is coming through that pixel of the image. And this is what I mentioned earlier, a great way of looking at algae in ice. So then there's another question in the feedback, and that's more on oceanography than an ice physics question, but I'll try to answer it anyways. To what extent the melting of the Arctic ice affect the salt concentration of the Arctic Ocean? And are there any other warming feedbacks in this context? So, well, let's start with the latter. The most known and important feedback here is, of course, the ice albedo feedback, meaning that if we melt more ice, we get a darker surface, so we get exposed ocean, or we form melt ponds that reflects less ice light, so we get more light penetrated into the ocean, and we get more warming, which in turn melts more ice. So this is very much a strong feedback process in the climate system. However, the salt concentration is also changing in the surface. So if there's a lot of ice melting because the salinity of ice is less than that of seawater, there is can be a freshening, and some of this fresh water can accumulate in areas of the Arctic. But that is, it's what oceanographer calls then fresh water is not necessarily what you would call fresh water as a normal person. So we are still talking of pretty salty water, but some slightly less salty water in the surface Arctic. And there's changes to that, and you can can do a lot of research on that, but that's again more our oceanography colleagues that do these large transects. Maybe again as a little reminder of where we are. So we are currently sitting in, or well, I'm sitting in Bremerhaven, but my colleagues are currently on Polarstern, and they are here in the ice. And you see the map. I've just activated the sea ice cover, and we are far into the pack ice of the Arctic Ocean. You see the ice concentration is high, 90 to 100%. So we are really measuring central Arctic sea ice and not just something at the ice edge. So I hope that told you a little bit about how the melting affects the salt. Of course, there's much more to that story, and we can have long talks only on the salinity content of the ocean water. So let's have a closer look at the main camera again. As you can see from the overview on the display, you can see this little green dot. That is the ROV. It shows the heading. We're currently going down the survey lines, and we are under solid ice. Now we're going forward again. You can see again ctenophores. You can see maybe there's even some algae clumps hanging in between these bubbles. It's very hard to see on these images. And just enjoy the underside of sea ice. Again, I want to remind you, if you have any questions or anything, you are welcome to use the chat tool, and then we are trying to answer these questions. You are looking at a real time diving video from the Arctic. This is streamed live over a satellite connection, and yeah, I am trying to help my colleagues out a little bit with providing some commentary for you, because they are actually doing their work. So we don't want to disturb them in their workflow too much, because they have to concentrate on operating the ROV, driving it. You can see we're currently pretty close to the ice. So that means, because we are in a depth of 2 meters, here we are also in a spot where the ice is going down, has a thickness of at least 2 meters, so the ROV has to go down to get underneath. And now you have a nice close view of the ice underside, and you can see how the ice surface is really rotten from the summer melting. All these pockets that you see in winter start out as little brine channels and pockets, and then these go down, and in summer they can open up and really make this sponge-like appearance of the ice underside. Another nice ctenophore comb jelly passing through the camera. Can even see that one in the back camera going out. Here you can see a very big block of ice, and it seems very dark, so there could be also some incorporated sediments or algae in this block. It's very hard to judge from just looking at it. One would need some samples, but you can see we're now down at a depth of 4.5, 4.6 meters. So the ice is obviously quite thick in this spot. And that is very typical for the Arctic, or generally for sea ice, that you have a lot of level ice, that's how we call it, that is about a meter, 2 meters thick, and then we have the thicker spots where the ice has been pushed together and then gets thicker. Okay, I'm actually pretty amazed that thanks a lot for all you viewers that we have still over 50 viewers on this live stream. It's great that you're all following. It makes me very happy. So it shows us that it's worth the effort to stream these pictures from the Arctic. Of course, there's still things to learn and improve on these streams, but it's already great that we have about 50, and sometimes we were even up to 60 viewers now on this chat. So the official time for the stream is over, but I think we are just going to continue until the colleagues stop the transmission, and it's probably going to be when they stop their optical survey. So yeah, enjoy these videos, and if you have any questions, feel free to ask. So I got the question if there is could be an influence from waters from the St. Anna Trough in this area, and for that, again, we need to quickly go back to the map where we have the thing, and you can I have to switch off the sea ice again, and then you can see where Polarstern currently is in the central of the basin, and you can see that from the Siberian shelf there's these troughs coming down, and they of course bring some shelf waters on here. However, directly under the ice, definitely we don't have waters from the St. Anna Trough here, because the current goes along the shelf line here, and all these currents from the shelf go into the polar current, which is following from Spitsbergen and Franz Josef Land around here. So it's kind of a barrier to the central Arctic. So it's not likely that there's song, but I haven't seen data on this, so I don't think so. So let's go back to our overview to see. Okay, we still have 1.5 lines left here in this survey. Thanks a lot for your positive feedback in the chat as well. That is definitely encouraging us to continue doing such streams and doing the effort to provide them to the public. Hopefully that's going to be a lot more in the future, but at the moment it's really the issue. At the moment it's good, but last year that wouldn't have been possible just because we never had the connectivity options on Polarstern to do these kind of live streams, because the limitations of internet access in the polar regions, which luckily has changed. So you can see the ROV is again in a area of that's probably very new ice formation. I suppose that it's not open water, even if it looks like that on the image, but it's actually a very thin sheet of nihilous ice, very young ice that is has been growing, and they want to investigate the optical properties of that ice as well. So they are going up there, and that's why there's not so much to see on the main camera at the moment in this part of the ice. And yeah, thanks. There's a nice comment to say, would have never thought that staring at ice would be so compelling. And I can only tell you, yes, I mean, it has been my job for the last 10 years to do this, and I can spend hours looking at ROV videos of under ice situations. So yeah, it's definitely great. If you are interested in seeing more of this, of course, all this data in the end is free. And for example, from the Mosaic expeditions, you can go to the public data archives on, for example, on Pangea.de, where you will find all the video files of the dives on Polarstern. This is not a very easy way of finding interesting things, but you will find everything that you can watch that has been recorded by us under ice. You can find on the archives and look for it and look for it for hours. So the data is there. However, I guess it's much more interesting to watch these videos with a bit of commentary about what you see in a live stream. So we can see the ROV has turned into what is probably the last survey line. The ROV is pointing towards the bottom end of the map again, and you have to see sometimes there's little jumps, and maybe I can talk a little bit about how we know where the ROV is at all, because under ice, the GPS is not working underwater or under ice in particular. So we are using an acoustic positioning system where we deploy 3 transponders underneath the ice, and then there is acoustics that is measuring the distance to these transponders, and from that the system derives a position. And that's also why these positions are so jumpy, and because this is all coming with inaccuracies, and after the dive all this is going to be merged in a final track line where we assume where the vehicle has been. But positioning vehicles under ice is very challenging, and also if you look at the details of the line plot, first of all you see that it's kind of jumping in these triangles because we have these 3 transponders, but also you can see that the vehicle does a few bends back and forth and doesn't really follow the lines straight away, and that is because of the fact that we are close to the North Pole, we are in the Arctic, we have significant problems with our compass direction. So yeah, it's a very big challenge to drive straight lines underneath ice. And you can see my colleagues today are doing a very great job in doing a great straight line. But due to these problems with compass, etc., we can't use automated heading, etc., for example, because um, these headings do change over time. Otherwise, on a traditional ROV, it would be very easy to do these kind of surveys because you would just set the vehicle on an automatic heading and it just follows a straight line. But this is not possible in the polar regions due to the navigational constraints that we have. So if you wonder about these wiggly lines, that is because we are in the poles and it's very challenging. So you can see we're coming to an end there on that survey. We don't know what is going on after that. Probably there's going to be some further dives that are maybe not that interesting. We'll see how long the transmissions last, and we just keep on transmitting it. There may be some advertisement again. So we are at the moment planning another live stream for Friday afternoon. That is a time at 4 p.m. Which is a bit more suitable to people who maybe have to work. If you stop early your work on Friday, you can fully enjoy the time here. We want to see if there's more or less people coming. So with the usual caveats, we don't know exactly how it works out with the station planning. It could be a polar bear on the ice, things could be cancelled. But otherwise, feel free to join the stream again on Friday. I'll also be trying to moderate that live stream. Because I hope that it is a bit more interesting than just looking at a straight on live stream. but we'll see. So now we got another few questions. One is, when are the biggest changes in Arctic ice in summer or winter compared to the last 40 or 50 years? Should, when and where? I mean, the biggest changes definitely are in summer. So winter sea ice extent hasn't been changing that dramatically, but it has also changed dramatically. So the biggest changes are definitely during summer in the Arctic. Um, but it's changing all over. Particularly, or if you compare it from the early satellite records, we are reaching a state where the summer or the winter extent that we currently tend to get is getting very close to what we earlier used to have in summer. And that shows you how much sea ice we have lost in summer, but also how much we are losing in winter. Um, it's tremendous areas of sea ice that we are losing and we are continuing to lose. So yeah, that's the biggest change in sea ice area. Then of course there has been kind of a regime shift in 2007 when a very exceptional year has happened, which has melted a lot of ice in the Arctic, and the Arctic has never really been able to rebound from that year to the state previous of that. So that is definitely a key year when a lot of these changes happened. But these changes are going on, and every year there's less ice, and the ice is becoming thinner. So now I got an interesting question about how is the ice drift affecting piloting the ROV, and that is actually a very interesting and challenging question. So the piloting itself, it's not that much of a challenge because basically the ice drift is just a relative current to the ice. We try to only operate up to currents of 0.2 up maximum 0.3 4 knots because above that, there's just too much relative current. If we have less relative current, it's no problem from the piloting side. However, this is exactly what also causes a problem um, in all the navigation situations. Usually, you navigate ROVs in normal geographic coordinates. However, as the sea ice is moving, um, all our true geographic coordinates, even of the pieces that are stationary on the ice, are continuously moving. And that is a big challenge for a lot of the navigation software and for the data post-processing, because you suddenly have to adapt for a fact that the ice is actually moving. So that's one of the reasons why we deploy these transponders, and then we use a local reference frame to kind of get rid of the sea ice drift, and we are only left with the pieces that are left due to the drift, and that is easily compensated by the pilot. There's some trim toggles where you can just adjust so that you drive straight lines anyways. So we have somehow slowed down a little bit. It seems like we are doing a high resolution survey of this thicker blob with the hyperspectral camera that you just previously saw. Exactly. Marcel is right now pointing the camera again at our stream setup, but also at the hyperspectral camera, and you can now see here in the display of the hyperspectral camera on the right side, you can see a reconstruction of a normal RGB camera, and on the left side, you can see the spectrum for each for some example pixels here, and you can really see differences. And I assume they found some algal spots here, and you can see we're going back to the location where the ROV has been deployed. So there's a question if the ROV position cannot be referred to the Polarstern position. Yes, it can be. The problem is also Polarstern is usually moving a little bit relative to the flow because it's not usually not easy to keep a ship perfectly stable against the flow. It's also moving um, it's moving a few meters back and forth. So what we sometimes rather do is we actually measure the motion of the flow and then use the acoustics to get to a true position. But yeah, acoustic positioning under ice is a big challenge. And in this case, we are not measuring the acoustics directly from Polarstern, but actually from the operation cabin that is located on the ice itself. And also talking about accuracies with GPS, you can get down to accuracies of millimeters with research grade systems, but with acoustic sensors, you typically get just to positioning accuracies of maybe 10 centimeters, sometimes even just about a meter. So it is a very challenging subject to know precisely where you are. And in the Arctic, it's very crucial to know where you are so that you know where you can go. So let's have some close looks again at the underside of the sea ice. You see this typical part of the underside of sea ice. You see again some brighter patches, some darker patches, and I assume we're going back to the deployment hole now, and then you maybe see the recovery procedure for the vehicle. Okay, so we're going back close to the ice, and now you actually see the hole that has been cut into the ice for deployment of the ROV. You see the tether cable coming out there, and the very bright spot above, and that is the hole where the ROV was deployed through. And yeah, now we seemingly have passed it, but you will see if we switch to the main camera now, to the overview again, that my colleagues are now trying to surface in that area and get the vehicle back on board. You also see that's the reason why Marcel has the radio in hand to communicate with the person on the hole handling the tether. And now we are rising up until you get another close view of the ice, and somebody hooked it with a Bosum's hook, and the vehicle has been switched off. You can see that the pan and tilt has really changed. The vehicle is hanging freely, not actively. There's another question. It says, is heading the different from Polarstern? No, heading is a magnetic heading measured by the ROV that is mostly used internally, that is used as display on the maps. However, this is not necessarily the true compass heading and direction. So as I said earlier, we have a lot of compass issues, and this heading value is not necessarily the true accurate geographic heading, but is a reference for our work. So the ROV is back at the hole, and I think the stream has stopped now. The transmission of the vehicle. We had now about 1 hour of transmissions, one optical dive. I thank you a lot all for watching. We will stop this transmission now. As a reminder, Friday afternoon there's going to be another dive of that. With that, thanks a lot for watching. Maybe a little plug. you see me commenting in the chat also using the name Sea Ice Stories. I have my own little YouTube channel as well. Otherwise, you can check that out with regular videos also on my last expeditions. You can go to the Alfred-Wegener-Institut YouTube channel and check out there. We have quite some material on our ROV dives there as well, and also generally about the research the Alfred-Wegener-Institut is doing. And with that, I want to thank you a lot for watching, and I think I've answered all questions in the streams. Thanks a lot and have a great day.